Multiplying out for the warm-up, we should have, how about an x plus 6, an x minus 4. X times x is x squared, negative 4x, 6x, negative 24. Those are in common. X squared plus 2x minus 24. Same game, 2y plus 3, y plus 5. I didn't have time to do that. 2y squared, 10y, 3y, 15. 2y squared plus 13y plus 15. Okay. We multiplied out. Right now, we have one strategy for factoring, which is find what's in common, the greatest common factor. For taking an expression that's relatively complicated, it's got an x squared term in it, and rewriting it so there's no x squared term anymore. Our next step here is I'm going to give you a new method that's going to help us factor terms or factor polynomials that there is no greatest common factor. Specifically, we're going to use this to factor trinomials. Okay. The method is called the box and diamond method. Does anyone want to take a wild guess why I'm calling it the box and diamond method? Lily.
Because it uses the box method and the diamond.
Okay, it uses,
or the diamond, I don't know.
Uses the box multiplying and solving diamond problems. Okay, two things that we're, if not really good at least familiar with, and we've been exposed to. Okay, for factoring, we're going to use this method for factoring trinomials. Okay, when we see trinomials, three-term polynomials, this is the method we're going to probably first think of. Okay, the box and diamond method goes as follows. Okay, it's, as you can see, I've got 6 steps for you. I'm also, while I do this, I want to be pretty clear. The first time I give you the directions, I'm going to write each direction, and I'm going to try to solve this first example problem along the way. So hopefully we'll be able to see kind of what I'm doing as I give you the steps. Okay. The first step is we're going to factor out the GCF, if possible. If there's something in common, I want to factor that out. So when I ask you to factor, say, this trinomial, the first thing I'm going to do is say, is there anything in common? Is there anything in common amongst all 3 terms? Specifically in our example, amongst x squared, 3x, and 2. Is there anything in common, any factors in common? They share, say, an x. Not all 3 do. So, no. The first 2 do, but the last one doesn't. So they don't all, we can't factor an x out. How about, do they share any coefficients? Do they all share 3? Do they all share 2? No. There's nothing in common, or the GCF, or more technically, the GCF is 1. So the GCF is just 1. There's not really anything to factor out. That's usually good. Step 2. We're going to create a diamond problem in the following way. We're going to create the diamond problem in the following way. It's going to be 2 steps. First, I'll draw a diamond. So if I'm going to try to factor x squared plus 3x plus 2, I better draw a diamond. You'll notice as I do more, I'm not going to put the outside lines, so I'm just going to do the little cross hatches. I'm going to create and fill in a diamond problem the following way. First, I'm going to multiply, well, the multiply box is the first and last terms multiplied. So if I want to factor, say, this trinomial, x squared plus 3x plus 2, I'm going to create a diamond problem. And in the multiply box, which is, which box in the diamond? Where's the multiplied together box on a diamond problem? The top one. In the top box, I'm going to put the first and last terms multiplied together. So in our case, the first and last terms are x squared and 2. So what do you get when I multiply x squared and 2? 2x squared. That goes in my multiply box. That's the top box. Okay. I'm also going to, the second piece is that in the add box, put the linear term, which for us is the middle term. The technical name for it is called the linear term because it's an x to the first power. In our case, if it's written in standard form, it's just wherever's in the middle. So in the adding box, where's the adding box on a diamond problem? On the bottom. And so then what goes in our bottom box in our case here?
3x.
3x. Here comes the hardest part of the whole thing. Step 3. Solve the diamond problem. You just made. Here's the hardest part of the entire thing. Solve the diamond problem. Okay? So looking at our diamond problem, what's the solution to this diamond problem? Our first example. Sarah, what was it? 2x and 1x. Multiply to get 2x squared, they add up to 3x. So in our side boxes, we'll put the solution to our diamond problem, which is 2x and 1x. So far, so good. Am I going too fast? Does this seem like we're okay so far? Okay, there's the diamond part. Now we're going to do the second part of the title, which is the box part. So step 4. We're going to draw a 2x2 box. 2x2 box. Fill it out in the following way. Okay, 2x2 box looks like this. There's a 2x2 box, and we're going to fill it out in the following manner. There's 3 things. First one, in the upper left, is the first term of the polynomial. In the upper left box, we're going to write the first term of the thing we're trying to factor, or try to break down into 2 groups multiplied together. So what goes in the upper left box in my example here? X squared. Okay. First term, first box. Lower right equals the last term of the polynomial. in the lower right box. So we're going to put the last term of the polynomial I'm trying to factor. In our case, what should it be? 2. And last but not least, the remaining boxes are the answers to the diamond problem. The remaining boxes are the answers to the diamond problem. You can fill them in whichever order you so choose. It does not matter. The answers to the diamond problem you created go in the remaining boxes. I'm going to put them in this order. You don't need to, but about 2x and 1x. If you flip-flop them, you will still get the right answer, the same answer in the end. Not matter. These two are kind of fixed, and then we put these in whatever order we want, as long as they follow those rules. Now it goes on cruise control. Step 5. Find the GCF of each row and column. That's what's in common. And then we'll write those above and to the left of the box. This part is totally arbitrary. I choose above and left. If you want to do below and right, below and left. If you want to do above and right, it does not matter. It's just where you're writing your answer. Just keep them constant. Keep them consistent. I like above and left. Anyone want to take a wild guess as to why I'm going to write the what's in common above and to the left? That's kind of where I liked it. How did we notice that this looks eerily similar to a box multiply? Where did I put the things I was going to multiply when I box multiplied? The left and above. So I'll do the same. Okay. In the end, what we're doing is this is the answer to a box multiply question. We're trying to find what the question was. Okay. Our goal with factoring is that we're taking this complicated thing with an x squared and rewriting it and trying to figure out what got multiplied together that has this as an answer. Well, notice that this box was a tool for multiplying. So if we could figure out what had to go above and to the left here to multiply to make this up, then we've done just what we wanted to. One strategy is to find what's in common. So let's say for each row and column, rows go left and right, columns go up and down. So it doesn't really matter how we do this. I'm going to go row by row first. So what's in common in our first row? X squared and 2x. What's in common here? X. So since that's in common, I'm going to write that to the left. X was in common there. What was in common here between 1x and 2? A 1. Right? There's no x's, so we can't write an x. The only thing that's in common is, like, 2 doesn't go into 1, but 1 goes into any number we want it to. Okay? So if you can't find anything else, what the GCF or what's in common is going to be a 1. And note it's a, well, we'll get that. It's 1. We'll do the same thing with the column. So we'll go up and down. So what's in common between x squared and 1x? An x. How about a 2x and a 2? So if we did this correctly, the things on the outside, if we multiply down and across, should fill in this box. Okay? So your check is, what's x times x? Okay? What's x times 2? Okay? What's 1 times x? What's 1 times 2?
2.
2. Okay. These numbers multiply out to give us what's in the box. Okay. So what that means is that if I were to multiply this binomial times this binomial, I should get x squared plus 2x plus 1x plus 2, x squared plus 3x plus 2, which is exactly that answer. So my solution then, or step 6, is the factors are now written outside of the box. Write them as a product. Product being multiplied together. So then my final answer for this factorization should be x and a positive 1, x and a positive 2. This is identical to this. X squared plus 3x plus 2 is the same as x plus 1 times x plus 2. Okay. You can check your work. You know that you factored this correctly. If you take this and multiplied it using a box, or with distributive property, or with FOIL, and you should end up with the original thing as the answer. It's the same line of logic that we used earlier in the chapter, where we used GCF, and we said, okay, here's the common factor. What multiplied with that had the original thing as its answer? What do we multiply together that gives this as an answer? Okay? And in this process, we can discover that. Okay? This box and diamond method is amazing because it allows you to factor just about any trinomial that's factorable. Okay? If you go and ask your parents how they factored when they were in high school, or probably even just an older brother or sister, the old school way to teach factoring is to just do about 70 problems a night until you do so much practice that it's just like ingrained in your skulls. This is a method. This is a very systematic way to factor. So the only real thinking involved is the diamond problem. So with any luck, we won't have to do about 80 problems a night for the next week and a half to teach factoring. Okay. We do need to know the method. Okay. Just like Jim. I'll zoom in a little bit. Okay. I want to try to factor t squared minus 8t plus 12. Okay. What's the first thing I need to do if I'm going to use this method? It is not make a diamond. Okay. Always check that. That'll make your life much easier down the line. Okay. Well, we're going to start off where we probably won't have much. We probably won't have much in the way of a GCF. But come next week when we start trying to kick up the difficulty a little bit, I may throw that at you. Always check that. It's very important. So is there anything in common? I don't see a t involved in all three, and this is a leading term of 1, so probably not. No GCF, or at least GCF of 1. Okay, so what's next? Okay. Jacob just told me I heard one person answer my question. What do we do next after we've checked the GCF? Create a diamond. Okay, how are we going to do that? Great.
You add the first and the last terms, and that goes in the multiplier. Nope, I'm lying.
You wrote it down. Just read it to me. It's okay. So what should go in the top box? 12 times t squared. 12t squared. What goes in the bottom box?
Middle term.
The middle term is minus 8t. If you wanted to, you could rewrite this as plus negative 8t, so we don't forget the negative sign. All right, so we've created a diamond problem. What's number 3 then? What do we do next?
Solve the diamond problem.
Okay, what's the solution to the diamond problem?
6t and negative 2t.
Yes. Sarah's on a roll. Sarah's on a roll. Note that since they multiply to a positive number, they both better have been the same sign. Since they add up to a negative, they both better be negative then. And negative 6 and negative 2 multiply to negative 8. Okay.
No, they add.
add to negative 8. You're absolutely right. Okay, what's so we've done step 3. What's our next thing we do? Okay. Okay, how do I fill this thing in?
Upper left.
Okay, so what goes in my upper left box? What is the first term?
The first term in the answer to diamond box. Just kidding, I'm lying. And then your lower right one is the last term.
Okay, so what's the last term of this polynomial?
12.
Okay, so what goes in the remaining boxes?
The answer to
Does it matter which order I put them in?
No.
Okay, we're moving. Okay, find the greatest common factor. It's for each row and column. Okay, how about, let's do columns this time. What's t squared minus 2t? What's in common? Okay, negative 6t and 12.
Oh, the 6.
Our rule of thumb is going to be if they're not the same sign, we're going to write positive value on top. We may have to adjust that at the end, and we'll see. Actually, this is an example of that, and we'll see why. Okay, let's do rows here. T squared minus 6t. Negative 2t and 12.
Negative 2.
Okay. Our rule of thumb says since they're different signs, we'll write positive 2. Okay. Let's double check to make sure this is correct then. If this is the correct factorization, then if I multiply what's on the outside, I'll get what was in the middle. Okay. So t times t, t squared. T times 6, t times 6.
6t.
Okay. It should be negative 6t. That's a problem there. Our first thought is maybe we make this a negative 6. Okay. Okay. Well, let's continue on then. How about what's 2 times t? It should be negative 2t. If we make this negative, what's negative 2 times negative 6? There's my positive 12. So t and a negative 16 and a negative 2 is the correct factorization. Okay. This is something that comes up really only when if you're noticing patterns. This is something that only really comes up if the middle term is negative and the last term is positive. This is the only time you'll have to change these values. All right, since we got those, our factors are now written outside. Write them as a product. So the correct factorization of that would p minus 2, t minus 6. You could have written this is equivalent to t minus 6 and t minus 2. It doesn't matter what order you write the factors in. On the back side, I want to do the top left one with you. Okay, so I look at this. I see t squared plus 9t plus 14. First thing I look for is greatest common factor. Nothing in common amongst all three. Diamond. Multiply the end terms. 14t squared, middle term. Solve the diamond problem. Multiplies the 14 adds to 9, 2t, and 7t. Probably.
Wait, why is 7? Where? Oh, I get it. Okay.
Okay. Now I'm going to draw a box. Fill in the box. First term first. Last term last. Answers.
Okay.
Now I'll find what's in common. Rows and columns. Rows here is a T, it's a 7, it's a T, and a 2. So my answer then is T plus 2, T plus 7.